Hi, welcome to your favorite TV show. This is another edition of Admiral Science, and today we're talking about balancing equations. Before we balance equations, we got to understand what the law of conservation of mass or matter is. It said that matter cannot be created nor destroyed, but is only transformed into another substance. Basically, what you start off with, you're going to end up with in the same number, except for that it may be a different type of substance. Alright, so you're going to start with something. You're going to start with an element or a compound or a molecule or something, and you're going to end up with the same number of elements or same quantity of elements that you started off with. You're going to end up with. Alright, so here we have some formulas and equations. Alright, so NaCl is a formula. Na plus Cl yields NaCl is the equation. Alright, same here. H2O. H2O is the formula. It shows the molecule, the compound, H2O. Alright, but H2 plus O yields H2O. This is the equation. So I think it's very important that we know the difference between the formula and the equation. The formula is simply the molecule or the compound, whereas the equation has several parts. And we're about to go through those parts now. Alright, so the equation has subscripts, coefficients, reactants, products, the yield error. Whoa, that's a lot, right? Well, let's break it down even further. Alright, so let's go back and look at our H2O. Alright, so this H2O, this 2 right here, this is what is known as a subscript. And the subscript says how many of the element that it is next to has. So for example, this 2 right here tells me that I have 2 hydrogen. Alright, if I had a 2 right here, it'll tell me that I had 2 oxygen. But because the 2 is right here in front of the H, it tells me that I have 2 hydrogen. So subscripts simply tell you the element. Alright, so coefficients identify the number of molecules. So just like this tells me the number of elements, let's see if I write a big 2 right here. This big 2 in front of the entire molecule tells me how many of the entire molecule I have. So how many H2Os I have. Alright, so if I have 2 here, this is a coefficient. And it tells me how many of the entire molecule I have. So if I have 2 here, that means I have 2 H2Os. So let's see, I have 2 H2Os. So I have this H2O and I have this H2O. So now that I have 2 H2Os, how many hydrogens do I now have? She said 4, because I have 2 here on this H2O molecule and I have 2 here on this H2O molecule. That gives me 4. So what the coefficient, to find out the number, you got to take the coefficient and multiply it by the subscript. Alright, so typically if there's nothing, if there's no number right here, then it's simply a 1. It is known to be a 1. Even if there's no number, if there's a number right there or if there's no number right there, it's a 1. Alright, but if there is a number like 2, then this 2 goes for the entire molecule. So coefficient, you take the coefficient multiplied by the subscript. Same here. If there's no number beside the oxygen, it's automatically assumed to be a 1. Alright, so 2 and 2 is 4, 2 and 1 is 2. So you have 2 oxygen, just like right here, you have 2 oxygen. So you take the coefficient and you multiply. So then we have reactants and products. So if we go and look at an equation, Na plus Cl yields NaCl. Alright, so reactants are the part of the equation that is being combined or separated. Alright, and it's typically away from the arrow. So here you have the arrow pointing this way. So whatever is the arrow pointing away from, that's the reactants. For this equation, this is the reactant. Alright, and so if that's the reactant, then the end result is the product, and the arrow will always point to the product. Alright, the arrow will point you to the product. Alright, and this arrow right here is known as the yield arrow, and it tells you the flow of an equation. It should go from reactants to products, no matter what. The arrow will show you the flow of the equation from reactants to product, whether the arrow points that way or whether the arrow points this way. If the arrow points this way, this side then becomes the reactants, this side then becomes the product. Alright, so let's identify some reactants and products now. So here we have GaF3 plus 3CS and we said the arrow shows us the direction or the flow of the equation. So if the arrow points to the product, we know that this side is the product now, because the arrow is going to point us to the product. Alright, and that means that this side then is the reactants, because the arrow points away from the reactants. Alright, same here. The arrow is showing us the flow of the equation, so we know that this side is the reactants because it goes from reactants to product, and this side is the product. Alright, now let's look in here. Alright, so this time the arrow is pointing this way, and it's split up. So let's see that this side then must be the reactants, because remember the arrow shows us the flow of the equation from reactants to products, and this side is the product. Plain and simple, right? Good. Alright, so let's label our parts now. So now that we know, let's start off. It says product, reactant, subscript, coefficient, and yields. So let's start off with our arrow. We found our arrow. This is our yields arrow. Alright, and then so it shows us the flow of the equation. It says it always points to the product. The yield arrow always points to the product, so we know our product. And this side is our product, and that means that this side is the reactants. Alright, now we have these numbers to decipher. Which one is the subscript, which one is the coefficient. The subscript, remember, it's a small number, it's next to the element, it's not in front of the whole number. Alright, so this small number that is next to the element, that is a subscript. And it says how many of that element we have. Whereas this number right here is the coefficient. It shows how many of the entire molecule we have. Alright, so this is the coefficient. Alright, so the coefficient tells us the number of molecule, the subscript tells us the number of the element. The number of elements on one side must equal the same number of the same element on the other side. So what you start off with, you must have the same number. It may not be in the same order as you started off with, but it needs to be the same number. So if you have 6 oxygens on one side, I expect you to have 6 oxygens on the other side. If you have 8 hydrogens on one side, I expect you to have 8 hydrogens on the other side. You can split them up on the other side. If the equation calls for them to be split them up. But as long as the total number on one side equals 8. Alright, so here we have P4 plus O2 yields P2O3. So first thing I like to identify is our reactants and products. So we have our reactants, we have our product, and then I want us to identify the number of each element. So P, we know we have 4. How do we know we have 4? We just look at this number right here. Oxygen, we have 2. Alright, on this side, P, we have 2, and oxygen, we have 3. So is any of these numbers equal already? No, they're not equal. Alright, so there's no one set way of how to start this. You can start this any type of way you want to. I typically just started with the number I can find the easiest common number. So between 2 and 4, a common number between 2 and 4 is 4. Alright, so if we have 4 on this side, we can easily get to 4 on this side for phosphorus. So how will we do that? We can't simply change this number. We don't touch the subscript. We cannot touch the subscript. We can't change that number. You can change the coefficient though. Alright, so remember, it's automatically assumed to be a 1 if there's nothing beside it. Alright, so we're going to just put our 1 for placeholder. So this is 1, so that lets us keep this even. And if we added 2 here, how many phosphorus molecule atoms do we have? 4, because 2 times 2 is 4. Alright, so now we have 4. So now the phosphorus is our balance. But if we change the 2 here, and that means that this is 4, but this also applies to the oxygen as well. So now the oxygen is 6. So now we have 2 and 6. So we have a common number between these two, don't we? Yes. If you said 3, because if we do 3 here, 3 times 2 is 6. So now we're balanced. Now we got 4 on this side and 4 on this side. Then we got 6 on this side and 6 on this side. Alright? So remember, the 1s is automatically there if there's nothing beside it. It's a 1, and you just look at the number. So coefficient times the subscript will get you the number, lets you know how many you have. So 1 times 4 is 4, 3 times 2 is 6, 2 times 2 is 4, 2 times 3 is 6. Let's do another practice problem. Alright, so let's identify reactants and products. This is the reactants, This is the product. Alright. We have how many nitrogen right now? 2. How many hydrogen? We have 2. Alright. Right now, how many nitrogen do we have? We only have 1. How many H's do we have? 3. How did I get that 1? If there's nothing beside it, it's automatically assumed to be a 1. Alright. So, let's see. Is there a common number between 1 and 2? Yeah, 2. Alright, so we leave this as a 1 and make this a 2 because we got the 2 on this side. We just wanted 2 on this side, and take 2 times 1, that will get you 2. But now, remember, if we change this number, the whole molecule changes. So this is now 2 times 3 for the hydrogen. It has 3, so now it's 6. So their number between 2 and 6 is common? Yes, it is 3. Alright, so now it's 6. Alright, so 1 times 2 is 2, 3 times 2 is 6, 2 times 1 is 2, 2 times 3 is 6. Alright, so remember, everything has to be equal. Alright, doesn't matter in what form, as long as the element itself is equal. Alright, and that there's no way to start it. There's no true way to start it. You just start with the number that you find the easiest to get a common number with. So for example, we started off with 2 here. That was a common number between 1 and 2, and it was easier for us to get 2 here. Alright. Here's a practice problem. I want you to pause the video right quick. I want you to try this on your own. It's better to try it on your own, get it wrong, so you know what you messed up before. Pause it now. I'm going to continue. Alright. This side is the reactants. This side is the product. Alright. C, H, and O. Alright. Then we have C, H, O. Alright, so let's see how many carbons we have on the side. So because it has no number beside it, it is a 1. For hydrogen, it's 4. And for oxygen, it's 2. Alright, let's look at this side. For carbon, again, that's 1. So they're even. Look, they're even. For oxygen, it's 2. Oh, look at our oxygens. They're even. Oh, no, it's not. See? Please don't make this mistake. You have this oxygen in here, that's 2, but you also have an oxygen here. So that's 3. Alright, so we have oxygen here and oxygen here, that's 3. And our hydrogens are 2. So we have a lot to work with. Alright, so let's see. We have carbons, they're balanced, alright? But they probably won't stay balanced because you're going to have to balance the other elements. So let's look at hydrogen. Hydrogen, we have a common number, 2 and 4. So let's focus on hydrogen. If we leave this as a 1 for the time being, if we leave this as a 1, keep that as a 4. And what number can we put right here to make sure that this is 4? 2. Alright, so now, that is now 4. So our hydrogens are balanced. Now our oxygens. Remember, now that you have changed this to a 2, this is no longer, this oxygen is no longer 1. It is now 4. I mean now 2, I apologize. It is now 2. So now let's count our oxygen. So we got 2 here, hydrogen, I'm sorry. You're right, oxygen. You have 2 here, and you have 2 here. That gives us 4. So is there a common number between 2 and 4 that we can use? Yes, 4. Alright, so if we can get this to change to 4, we'll be balanced. And what number can we get to change it to 4? 2. So now that this is 4. So now it's balanced. 1 and 1, 4 and 4, 4 and 4. Alright. So let's look at this next equation. Now we see some things that are different. We have this parentheses bracket here. Alright, so why would we have a parentheses bracket here is because, well, this whole thing is a molecule. And if we put a coefficient here, it applies to all of this molecule. But because it's only supposed to apply to this molecule, they put a parentheses so that way this 2 goes for this part of the molecule. And so you take this 2 and multiply it by the next subscript. So this is just a subscript within a subscript. 2 times 4, 8. 2 times 1, 2. Alright. Alright, so how many nitrogen do we have? 1. We have 3, 2, 5 hydrogen. And how many sulfurs? 1. How many oxygen? Alright. Now, on this side, how many nitrogens? Well, 2 times 1 is 2. How many hydrogen? 8. How many sulfur? 1. And how many oxygens? 4. Alright, so let's take a gander. This is a lot to work with. So let's see. We have 1 nitrogen here, we have 2 here, so that's an easy number to work with. Hydrogen is 5 and 8, not so pretty. Sulfur is 1 and 1, so that's already balanced. And the oxygens are 4 and 4, so they're already balanced. So let's look around at nitrogen. Nitrogen, we said 2 and 1, number is 2, so let's see if we can get to 2. Alright, so we'll just add a 2 here. So we add a 2 here, that changes this whole molecule. This is now 2, and this hydrogen is now, so now we increase it, this is 6, 7, 8. So now we have 8 here. So, hey, look how easy that was. We're already balanced. And we can just put our 1s right here as placeholders. Because look, our nitrogens are now 2, our hydrogens are now 8. Our sulfurs are 1, and our oxygens are 4. Balanced, perfectly balanced. Pretty good. It's not that hard. I mean, it may look like a lot to decipher, but sometimes it only requires this one little change. So let's look at this monstrosity of an equation. This seems like we have a lot to decipher. Alright, we have those parentheses things again. And remember, the parentheses apply to this part of the molecule, so this subscript only applies to this part of the molecule. And we have a lot to decipher. Each part has some parts to it. So let's go through our order. NaPO, CaCl. And on this side, NaPO, CaCl. So we have a lot to decipher. Alright, so let's break it down with our numbers. 3, how many phosphorus is 1, oxygens 4, Ca's 1, and Cl's 2. Alright, for Na on this side, we have 1. How many phosphorus? Remember, 2 times 1 is 2. How many oxygen? 2 times 4, 8. How many calcium? 3. And how many chlorines? 1. So let's look at our numbers. 3 and 1, 2 and 1, 4 and 8, C, A is 3 and 1, and 1 and 2. So let's see if we can get a common number. I like the P's because they're 2 and 1. It's a small number we can work with to start off with. Remember, there's no way to start it off. There's no surefire way to start it off, but I like to start off with common numbers. So 2 and 1. And we put a 2 here to get the phosphorus to 2. That changes everything. So then the sodium is now 6. Phosphorus is now 2. And the oxygens are now 8. So for the most part, our P's and our O's are balanced. They're at 8. So I don't want to touch this part no more. If anything, because the sodium changed, I want to change this sodium because I don't want to touch it. This is already balanced. I love it. So that's what we're going to stick with for right now. Alright, so 6 and 1, common number there is, of course, with any number that involves 1, the common number is the other number, so 6. Alright, So if we change it to 6 and we got our sodium to 6, our chlorines now go to 6. Alright, but that's a better number to work with here, so because 2 and 6 have a common number, which is 3. Alright, so if we want to change the chlorine to 3 to get that to 6, we have 6 here, and now that gives us 3. Voila, it is now balanced. Alright, 6 and 6, 2 and 2, 8 and 8, 3 and 3, 6 and 6. Alright, so remember that you take the coefficient and you multiply it by the subscript. Remember, if it doesn't have a subscript, that means that it's automatically 1. If it doesn't have a number in front of it, that means it's automatically a 1. Alright? But everything else is just multiplying. Making sure you have the same number on this side as you do on this side. No matter where it's at this location, as long as it has the same number on each side, so that it's perfectly balanced. 2, 3, 6, and 1. So that all the elements are equal on the same side. So we got reactants and products, and they're equal. Alright? Any questions, please go back and review any of the steps you did not understand. If you have any questions, please leave a comment in the section below. I'm here to help you, assist you, and this has been another edition of Admiral Science. Look forward to working with you in class. See you there.